In a digital maze, through the data haze, MetaCrawler moves, bringing structure and grooves.
Hi, my name is Shannon, and today I'll be showcasing where we are up to with the prototype for MetaCrawler. MetaCrawler is a semantic file crawler that reads, sorts, and classifies files. Its agentic features allow it to create richer and more meaningful metadata than traditional computer algorithms. The current version is designed for reading documents, including optical character recognition, but it could be easily extrapolated to handle other modalities such as video and audio. Instead of relying on file extensions, we're using MIME types to more accurately assess the type of file. Anything strictly text-based can be passed straight to AI agents for processing. Images, Word docs, spreadsheets, and PDFs, including scanned documents, are first sent to a Zero AI document intelligence to be converted to text before being sent to the agents. We also convert the text into tokens so that shorter documents can be sent to a lightweight LLM with a smaller context window, and larger documents can be chunkified first. This is all still being built out, so for now, everything is going to ChatGPT 4.0. Each meta tag is assigned to its own agent, which allows for greater flexibility in engineering the system prompts and increases the quality of the meta tags produced. This also means that each agent can have its own LLM model swapped in and out individually. For this early prototype, we're focusing on two main meta tags so far: a summary of the file, stored as both text and a vector embedding, and a list of hashtags describing the file. The use of generative AI unlocks a plethora of new areas of metadata and also nuances to existing ones. Some of the meta tags we're excited to build next include privacy classification, which can be handled in a multitude of ways depending on risk appetite, and also relevance, a fuzzy heuristic for version control that checks if a file is out of date or still relevant. As the files get crawled, they're checked against a Neo4j graph database. If the file is new and it has no node, the file will get processed, meta tags are generated, and a node is created, and MetaCrawler moves on. If a node for the file already exists, the last modified date is used to see if the file has been modified. If it has, the file will be reprocessed and the node updated. If not, the node is updated with the current walk time, and MetaCrawler moves on to the next file or directory. After the last file has been crawled, a cleanup algorithm runs and prunes any nodes that weren't crawled in the last run-through, keeping the meta index up to date and accurate. The use of a knowledge graph like Neo4j improves entity resolution and allows more complex relationships between files to be captured. This also means the meta index can be used for retrieval augmented generation without having to embed the whole file system first. Our team is looking forward to continuing the build in the coming weeks. Please do reach out if you have any questions.
In a digital maze, through the data haze, MetaCrawler moves, bringing structure and grooves.